Hello, everybody. Today we're going to be talking about chapter 2.1 in our biology books, which is about the nature of matter. And this is going to be a little bit of a review from hopefully some chemistry that you learned in middle school. Our learning objectives as we go through these notes are to identify the three basic subatomic particles that make up an atom, identify how isotopes are different than elements, and specifically what makes them different, how compounds are different than their component elements, and then the two main types of chemical bonds. So this is an atom. Um, Atoms are the basis for all living things. Your body is made up of atoms. The bed you're probably sitting on right now is made up of atoms. Everything surrounding you is made up of atoms. And atoms themselves, for what you need to know, are made up of three basic subatomic particles. You have protons, which have a positive charge, neutrons, which are neutral, and electrons, which have a negative charge. If I look here in the picture, both protons and neutrons are in what's called the nucleus of the atom, or the center. And then the electrons surround the nucleus. They're in this cloud that surrounds them, and they have the negative charge. There's the protons, there's the electrons. You can see that their charges cancel out. There's 6 positive charges, 6 negative charges that makes this neutral, and then 6 neutrons. So an element is the pure substance, something that's entirely made up of one atom. So this right here has an atomic number of 6. I can tell that because there are 6 protons in the nucleus. 1, 2, 3, 4, 5, 6. Atomic number is 6. That is for carbon. Um, Elements have all the same atoms, right? So if I'm talking about the element carbon, I'm just talking about this element that has 6 protons, 6 neutrons, and 6 electrons. But if I talk about isotopes, an isotope is a different version of that element. So for carbon, for example, there are 3 different isotopes. They're called carbon 12, 13, and 14, where all of them have the same number of protons, 6, 6, and 6. All of them have the same number of electrons, also 6. But they differ on the number of neutrons. That makes the nucleus slightly different and has slightly different properties. So carbon 12 would have 6 neutrons, carbon 13 would have 7, and carbon 14 would have 8. You see carbon 14 is a radioactive isotope, which means it's basically unstable, and it doesn't want to stay like that in that state of being unstable for long. And so carbon 14 being radioactive, like all radioactive material, will eventually decay and turn into something else because it's got all this energy it needs to get rid of. So again, isotopes, same number of protons, same number of electrons, but a different number of neutrons. Then we come to chemical compounds and how they have different properties than the elements that make them up. Think of oxygen and hydrogen. Those are gases in their pure elemental forms. But when you put them together, you get water. Think of carbon and oxygen. Carbon is a solid, and oxygen is a gas, and you put them together, and you get a gas and carbon dioxide. So the chemical properties that exist in chemical compounds are vastly different than what you get in the pure elemental forms, and that's because of the complexities of chemical bonding, of like bond angles, how they share electrons. That's a complicated process, and you'll learn a lot more about that when you take chemistry. All right, so next we're going to talk about bonding and how you get the formation of these compounds. There are 2 main types of bonds you need to know: ionic and compound bonds. Um, but all bonding in its basic form has to do with learning about electrons. So electrons, if you remember from just what we talked about, are contained in this cloud or shell that surrounds the nucleus. Um, what you need to know about that shell is it's most stable when it either has 8 electrons or 0. Um, and so because of those properties, elements can do different things where they either give away electrons or share electrons with other elements, to either get 0 or 8. So here's an example with an ionic bond. An ionic bond forms when one element donates one of its electrons to another element. Here's an example with sodium chloride. Sodium chloride is also known as table salt. Sodium here has 1 electron, and chloride has 7. The most stable form for both of them would be if sodium gave away one of its electrons to have 0, while chloride can take that 1 and it would have 8, and they'd both be stable. And that's what happens here in an ionic bond, right? So eventually what happens is that sodium, because it gave away its electron, will become positively charged, and chloride, because it accepted an electron, will become negatively charged. And think of magnets, right? Positive and negative attract. And so what they form here is called an ionic bond, where these are ions. Ions have different charges than the elements. Here's a sodium ion, it's charged. Here's a chloride ion, it's charged. They are bonded together by this slight electrical attraction here. That's different than a covalent bond. A covalent bond forms when elements, instead of donating electrons and becoming ions, they share electrons. So this is oxygen. Oxygen in its outer shell has 6 valence electrons. It's hard to see, but I'll point them out. So here's 1, 2, 3, 4, 5, 6. These 2 right here are from hydrogen. And these 2 in the middle don't count. That's the inner shell. So oxygen, it has 6 valence electrons. It wants 8. And so the best way for it to get 8 is it needs to share with a molecule like hydrogen. Hydrogen just has 1 valence electron. And hydrogen is a little bit of a unique case. Hydrogen actually needs 2 valence electrons to fill its shell. And so what happens here is hydrogen and oxygen share their electrons, where basically oxygen feels like it's fulfilled because it has 8 electrons surrounding it, while hydrogen has 2. So there's the 2 from the hydrogen, and then you have 8 total electrons surrounding the oxygen. And you can see here where there's shared electrons. The final thing we were discussing is something called van der Waals forces. If you've ever seen a gecko climb up a wall, it has these what are called adhesive toe pads. Adhesive toe pads work because of van der Waals forces. And van der Waals forces are these intermolecular forces of attraction, similar to like a magnetic attraction, which you see in an ionic bond. They form between slightly oppositely charged regions of nearby molecules. And the reason they can form is because of how close the molecules can get to each other. The closer the molecules get to each other, the more likely these van der Waals forces can be imposed on that item. So here's an example where there's a simple atom here, one simple atom and another simple atom. But when they become really, really close, like 5 nanometers or less, they actually align like this, where you have the nucleus, where it's got a slightly positive charge, and the electron cloud over here, which has a slightly negative charge. They actually come really, really close together, and you get this like slight attraction. And so the reason geckos are able to climb up the wall is because if you look at the picture here, there's just tiny little slits that separate parts of their toe pad, which allow their toe pads to get really, really close to whatever they're walking or standing on, which allows the atoms in their adhesive toe pads to get close to whatever they're touching and form these van der Waals forces.